Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So in the previous video, we did learn about multiple recursion calls. So where is that specifically used? Now you'll find in recursion a lot of questions, or in dynamic programming a lot of questions, which does involve this particular term, which is known as subsequences. Now, what is the definition of a subsequence? A sequence I can say a contiguous or a non-contiguous sequence. It can be a contiguous, it can be a non-contiguous sequence which follows the order. This is very important, which follows the order. This is what we call as a subsequence. A subarray is just contiguous, but a subsequence can be contiguous as well as non-contiguous. Let's understand. If I give you an array which is something like 3, 1, 2, okay, this is an array of size 3. Now, if I ask you subsequence, I can say 3 is a subsequence, I can say 1 is a subsequence, I can say 2 is a subsequence, I can say 3, 1 is a subsequence, I can say 1, 2 is a subsequence, I can also say 3, 2 is a subsequence, I can also say 3, 1, 2 is a subsequence. I hope that makes sense. This is a contiguous, 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 but over here 3 and 2 is a non-contiguous subsequence, but still it's a subsequence. 3, 1, 2 is a subsequence, but at the same time I cannot say 3, 2, 1 to be a subsequence because it's not following the order. You have to make sure it follows the order of the array. The order of the array is 3 has to be before 1, 1 has to be before 2. This is the order of the array. So please make sure, like, if you're taking 3, 2, 3 has to be before 2 in the array. So order has to be maintained in order to call it as a subsequence. Now, apart from 3, 2, everything other is a subarray. So a subarray can be a subsequence. Remember this. So all of these are subsequences. And also we can call as an nothing, an empty set as a subsequence also, because we are not picking up any elements from the array. That can also be called as a subsequence. So in total there are 8 subsequences for this n equal to 3 size array, and I want you to write a function which prints down all the subsequences. Now this can be done using a very famous algorithm power set, for which I've already made a video. You should definitely check it out, how to do it using power set. But over here, since we are learning recursion, we will not be doing that. We will be learning the recursive way. Okay, so let's first understand some pattern. Now the array was 3, 1, 2, and I say that 3 comma 2 is a subsequence. Now let's observe a pattern. Okay, let's observe a pattern. So the pattern is very simple. There were 3 elements. And I say that 3, I've taken 3, I have not taken 1, and I've taken 2. So if I do a take and a non-take on indexes, this index I'm taking, this index I'm not taking, this index I'm taking. And if I do this, then this is 3 and this is 2. Hence, I can get this particular subsequence. So that's the pattern. For an example, I say that, okay, how will you get this 1 comma 2 subsequence? Again, very simple. Not take, take, and take. Correct? If I ask you how will you get 3 comma 1? Again, very simple. Take, take, not take. Again, if I ask you how will you get 3, 1, 2? Very simple. Take, take, take. Again, if I ask you how will you get null? Not take, not take, not take. So what I am observing is, for every index I have couple of options. Either I say that I'm going to take it or I'm not going to take it. So depending on this, I will try to solve this problem. Okay, so you've got the intuition. Now let's look at the code. If specifically my task was to give you the intuition. Now let's look at the code, and this structure of code that I'm going to write is going to be significant in going forward. Like, you will see all the problems being solved using this particular structure of code. So you need to understand the structure of code, and it's a pattern that you have to keep it in your head every day till your. Anyways, let's get started. So we will always have an index. Remember this, we will always have an index. So by the way, just assume the array to be 312. Assume the array to be 312 with indexes indexed as 0, 1, 2. So assume you have an index and we have a data structure. It Let's assume it's a list in Java. In C++, it's a vector. Okay, so I've taken a array or list or whatever you wish to. So what I'll say is, okay, I know I'll have to start from 3. I'll have to go to 1. I'll have to go to 2. Correct? So specifically, I have to go till index 2. That's for sure. I have to go till index 2. There is no way that I can avoid that. So I can say my base case is if the index by chance is equal to n or crosses n, I'll stop. Or I'll print it rather. I will print the array and I will return. That's what my base case will be. Apart from the base case, what will I say? I will like, okay, please add in the array this particular guy, array of index, or I can say whatever list you are carrying, please dot add. In Java you can use add, in C++ you can use pushback in vector. Dot add array of I. Correct? Next, you will be like function index plus 1 comma this particular list that you're carrying, and whenever you this recursion will go and it'll come back. Correct? So whenever you come back, you'll be like, let's remove this particular guy. Why are you removing? I'll explain you. Don't worry about that. Next, you will like, let's go with the same list. Right? This is what the code will look like, and the structure has to be in your mind always. Okay, this is the case of take, this is the case of not take. Okay, now let's understand how this code works using a main function. So if I write a main function and I'm assuming you have the array as 3 1 2 rather, and then you call this function with index 0 and a empty array. Okay, so what will happen is this function basically calls this particular guy. If I just shrink it down, this particular guy. Correct? Next, whenever this guy is called, the index value is 0. This is an empty array, right? This line is no more not executed because n is apparently 3, because the size of the array is 3. Next, you say in the array add it. So your array will now contain the first element, which is 3. Next, you say let's call the function. So you're calling the function stating index plus 1, which you are saying that, okay, what I've done is I've taken the 0th index. Yes, I've taken 3. Let's move to the next index, which is 1. And please pass on the array 3. So this particular array, remember this particular array is the subsequence that you're trying to form. So we went over here, right? Now again the if base case will not be executed, and you will again say in 3, can you please add array of index of 1. Thereby this will make sure that the array is now 3 comma whichever is at the index 1, which is 1. After that you'll be like, let's do f of index plus 1, which is 2 comma with the array 3 comma 1. Now this function call will go. Please understand in deep. Next, f of 2 comma 3 comma 1 is the array. The base case will again not be executed. What will be the next step? I'll say again array 3 1. Can you please add array of 2, which is this time this 2. So please add it. So your array becomes 3 1 2. Perfect. So you have done for this. Let's call the next one. Index plus 1 is 3 with the array 3 1 2. Perfect. Now this will call another recursion with f of 3 array as 3 1 2. Correct. Now this time the base case is if index is greater than equal to n, and it's true, and it's true, and you're like, print the array, print this particular guy. So I can say if I'm maintaining an output screen, yes, if I'm maintaining an output screen, for the first time I will get 3 1 2 printed. Correct. Now you'll be like, okay, you've printed, now it's time to return. So let's return. You have returned. Now if you have returned, time to understand, your array is having 3 1 2. For the last index, you decided that this 2, yes, this 2 has to be picked, but you still have an option where you say, you did come up with 3 1. What if I do not pick the last index? Then the subsequence will stay as 3 1, because logically you came up with 3 1 and you wanted to decide for the last index, and I said, okay, please pick it. So you got 3 1 2, and I can say please do not pick it, so I'll get the subsequence 3 1. So in this way you can get both the subsequences. So over here, since you have added, 2 has been added, right? 2 has been added, you need to remove it. That's why we say 3 1 2, please remove array of, like, whatever is it. Since it will be at the last index, you can just remove the last index, which is array of index 2. This is why you remove. After removal, the array again becomes 3 1, back to the state it was, back to the state it came. It came as 3 1, it is back to that state. Once it is back to the state, you call the next index saying it's back to the state. I'll decide for this index, I'm not going to pick anything. So please go with 3 1. Had you not removed, then the array would have been 3 1 2, and you'd have passed this, which would have been wrong. So this time you call this. It goes f of 3 3 1, and this time again the index greater than equal to 3, true, print and return. So this time the printing will go and return. So this time the printing will happen for 3 and 1. I just remove this. The printing will happen for 3 and 1. So I will be over and I'll go back. And once this is over, I can easily come back. Let's come back over here. Now when you're coming back, you realize you went with 3 1 and you decided for the last index. Now you are at a position where you have a 3 1, right? So you have a 3 1 and you have done for this guy, where you have said key 1 will be taken. Now I'll say let's remove this 1. Thereby the array again becomes 3. What are the options? Whenever you're saying someone is coming up with 3, what are the options for this particular guy? You said, okay, please take, so you got 3 1. Now you'll say do not take, so you'll get 3, and then you can go on deciding. So in this way, yes, in this way, can I say I can easily do it? So you'll remove, and again you will call for f of 2 rather, and you'll call on with only 3. So this time again the call will go to f of 2 with 3, and again the same task will happen for the second index, because this time you're coming with 3, nothing, and this time you will again do a take. So 3 comma 2 will happen, and you'll say not take, so only 3 will happen. So in this way, every other subsequence can be easily formed. So I hope you have understood the entire concept, how the first call goes, then comes, how this call goes and comes. But the critical portion over here was to understand the remove. I'll give you a classical example to remember this stuff. Now imagine this is the trial room of a shopping mall, okay? And you went in there. Now tell me one thing, if you have taken a couple of cloths, assuming over here a couple of cloths is nothing but, I'm saying take or not take. You've taken a couple of cloths. Whenever you're trying the first cloth, where this, in this case it is like picking up the first item, you will have to take out your current dress. You'll take it off and you'll wear the new clothes, correct? And in order to wear the next set of clothes, you have to again take it off. Na? If you don't take it off, how will you wear? So this is why, if you have added it over here, understand, if you have added this guy, so this guy has been added. So in order to try non-addition, you have to remove this now. That's why it will be removed. That's the concept of non-removal. So in this way, you can draw the entire stuff. But I'll try to explain you this using a recursion tree, because that is how we will be doing across. So let's take the array as 3 comma 1 comma 2. Okay, so I've taken the array as 3 comma 1 comma 2, and this time let's take the recursion tree as f of 0 and an empty data structure. So initially at the 0th index, you'll be like, I can try, that means I can pick up 3. So if you pick up 3, you'll move to the next index, because for the 0th index you have picked up, so your data structure will only be containing 3. Or you can say, I will not pick up, hence the data structure will be moving empty to the index 1. Correct? Now over here, whenever I say f of 0 and f of 1 and f of 1 over here, you need to understand this function call was made previously and then it came back. So this 3, yes, this 3 which is added has to be removed, and then this function call will be made. You need to understand, this is how this pans out to be. So what I'll now do is I will super quick draw the recursion tree. So it's f of 0 empty data structure. You say pick, so it'll be like f of 1 picked 3. You'll be like not pick, it'll be like f of 1 do not pick empty data structure. You'll be like pick first index, do not pick this first index. F of 2 3 of 1. This will be f of 2 3 of 0, nothing. Again you'll be like pick, not pick. This will be f of 3 3 1 2. So whenever you reach the third index, yes, whenever you reach the third index, this can be printed. So I'm just marking it as green, that means it is printed. Then you go back, this time this recursion call will come, which is f of 3 and I just have 3 1. So this time this will be printed, so let's mark it as green. Next you'll go back. Now you can say this entire recursion is over, goes back, comes over here, f of 2 3, again couple of directions, pick and non-pick. So f of 3 comma 3 2 and f of 3 comma just a 3. So this will be again this time printed, goes back, comes over here, prints, goes back, goes back. So I can say this entire left stuff is done, where you have ended up printing 3 1 2 3 1 3 2 and 3. So 4 subsequences have been printed, and if you realize 4 subsequences were printed by taking the first element. Now the other 4 will be printed by not taking. Yes, the other 4 will be printed by not taking. So I can easily do it by not taking. That'll be an empty one. Again, you can decide to take the first index, f of 1 comma, that'll be 1. And again, if you decide to not take, it'll be f of 2 comma not take. Again, if you decide to take and to not take, it'll be like f of 3 comma 1 2, and this will be f of 3 comma 1. So if I decide this is the next printing, comes back, goes, next printing, comes back, f of 2. So over here, what can you do? Again, you can decide to pick and to not pick. So if you decide to pick, it will be like f of 3 of 2, it will be f of 3 of empty. So this will be printed, and then this will be printed. So if you carefully observe, the next set of elements were also printed, which is 1 2 1 and a 2 and an empty. So you also printed the next 4. So in this way you can easily print. So if I just show you the entire recursion tree, this is how it looks. This is how the entire recursion tree looks. Quite simple. And if you want the vertical order, this is how the function calls have been made. Yes, this is how the function calls have been made. But I'll still highly recommend you to go back and draw the recursion tree by yourself to understand it. Okay, so quite simple. So if I try to write it down in the code, can I say I'll be taking an array? So I'll just take an array. You can do it by yourself. 3 1 2, and I'll keep the n as 3. Okay, and I'll say print f. I've written a print function which will print all the subsequence. Starts with index 0 array, and then so let's write the printf. Printf, I can say index, I can say, okay, I need a data structure to carry all the subsequence. Let's take a data structure to carry all the subsequence. which is ds. Okay, so probably I can just call the vector int ds, and I can pass the ds over here. That's the better one. Okay, over here you can take vector int. Remember, it has to be passed by reference, so please make sure you take as a reference, and over here it's going to be n. Okay, perfect. Now can I say if at the moment it reaches n, or like it will always reach n because you're moving linearly? Can I print the data structure? I can definitely print the data structure. So please print the data structure, which is c out of it this, and after that you can just give an endl just to make sure that this is not done. Okay, and after that you can just do a return. So this is how you print it. Now I'll say take or the pick condition, take or pick the particular index into the subsequence. Correct, I can say that. So what I'll be like is, okay, if I'm taking it, I'll say data structure to push back. In Java you can use array list, and you can just give an dot add push back array of index. Okay, so this is what I've done. I've pushed back the array of index. In order to remove, it's very simple. You say pop back, that will be deleted. And over here I can say that printf, sorry, extremely sorry, printf index you have done for the current index, you'll move to the next, you'll take the ds, you'll take the array, and you'll take the n. And whenever you come back, now it's time to try the not pick or not take condition, where you say that this element is not added to your subsequence. Okay, that's what you simply do. Now over here, what will be the case? Over here I can say the case will be very simple. You'll be like printf, index plus 1, the ds, and the array, and the n. So if you just do this, and probably if you just run this, you will see all the guys getting printed over here. See, 3 1 2 3 1 3 2 1 2 1 2, and the empty one is getting printed over here. So you can also like ds dot size, if by chance the ds dot size is 0, you can say it's a null one. So you can also print the null, something like this. This will also make sure that the null is printed. So if I'll keep this C, the null is printed at the last, because not take, not take, not take. You can also do it in the reverse order. Yes, you can also do it in the reverse order, where you say that, okay, do not pick condition will be at the front. You can also do it in this way. You say do not pick condition is at the front. So if we again run it, this time it will be, see, first null came because not pick condition was executed, and then it printed. That's your wish. If you want to do the pick, if you want to do the non-pick, then it's your wish. Okay. Now coming across to the time complexity. What's the time complexity? Can I say for every index there are a couple of options? Valid. For every index you're having a couple of options, right? So for every index, if you're having a couple of options, can I say like it's like 2 over here, 2 over here, 2 over here, 2 over here, 2? For every index you're having two options. So the time complexity is definitely 2 to the power n, no doubt in this, right? And into, for every subsequence, you're using a for loop to print it. Like it's generally not n, but overall you can say it's taking a time of n to print. So near about 2n into n is the time complexity. Space complexity will be how much? What's the auxiliary stack space? So if you look at the recursion tree, it's like going from 0 to 1 to 2. So the maximum number of recursions that will wait are 3. If you carefully think, not more than 3 recursion calls will be waiting in stack space, at max 3, because the depth of the recursion is 3. So I can say the stack space is coming out to be big O of n, because the depth of the recursion that we can have at maximum is n. So I can say this is the time complexity, and this becomes the space complexity. As simple as that. And do I need to explain you anything else? I don't think so. I think, yeah, that is pretty much it. Just make sure you remember this: pick and non-pick. For every index, you decide whether to pick and not pick. Since there are 2 to the power n subsequences for a given length n size array, thereby we got 8 subsequences for the size 3 array. So guys, I hope you have understood this entire explanation, this pushback, pop back, add, delete, remove, everything. So just in case if you have understood everything, please make sure you give a like to this video. You can do that, right? And if you're new to this channel, please do consider subscribing. And yeah, with this, I'll be wrapping up this video. Let's meet in the next one. Bye bye. Take care. Whenever your heart is broken.